Welcome to my YouTube channel Madan Anant Mathematics. Today I am going to discuss some important questions of inverse trigonometric functions which are not part of NCERT book. So let's start with the first question, that is simplify tan half cos inverse 3 by root 11. Here I will start this question by letting half cos inverse 3 by root 11 is equal to x. So ultimately the given expression will be tan x. That means we need to find out the value of tan x here. Simple transformation will give you 3 by root 11 is equal to cos 2x. Using formula of cos 2x in terms of tan x, that is 1 minus tan square x upon 1 plus tan square x. Cross multiplication will give you the expression 3 plus 3 tan square x is equal to root 11 minus root 11 tan square x. Collecting terms of tan square x on one side and constant term on another side, we will have this expression. Simple transformation will give you this expression tan square x is equal to root 11 minus 3 upon root 11 plus 3. Rationalize the denominator, we will have this expression. Taking a square root, tan x is equal to root 11 minus 3 upon 2. And x is equal to half cos inverse 3 by root 11. Therefore, we have the answer. I hope it is clear to you. Coming to the next question. Here you can see a long expression we have on the left hand side. And we have to find out the value of phi. So we will start with writing 1 in the numerator of each expression as the difference of the two numbers. In the first expression I wrote 2 minus 1 with the help of these two numbers in the denominator. Here 1 is replaced with 3 minus 2, and in the last expression I wrote n plus 1 minus n. To use the formula tan inverse A minus tan inverse B. I hope it is clear to you why we are writing 1 as a difference of two numbers. So using the identity, we will have tan inverse 2 minus tan inverse 1. The second one will give us tan inverse 3 minus tan inverse 2, and so on. Now you can see here, you can cancel this tan inverse 2 with the second term of the second expression. Then tan inverse 3 will be cancelled with this tan inverse 3. Continue in this manner. We will see the last term tan inverse n will be cancelled with the previous term. So we are left with the two expression on the left hand side, tan inverse n plus 1 minus tan inverse 1, which is equal to tan inverse phi. Using the identity tan inverse A minus tan inverse B, we will have tan inverse n plus 1 minus 1 upon 1 plus n plus 1, which is equal to tan inverse phi. Simplify, you will have phi is equal to n upon n plus 2. I hope it is clear to you. Then coming to the next question. Here we have tan inverse A plus tan inverse B is equal to tan inverse C, that is equal to pi. And we need to prove that A plus B plus C is equal to product of the three numbers A, B, C. Here we will start with considering let tan inverse A is equal to x, tan inverse B is equal to y, and tan inverse C is equal to z. Definition of inverse function will give us tan x is equal to A, tan y is equal to B, and tan z is equal to C. Here you can see, as we assume tan inverse A, tan inverse B, and tan inverse C as x, y, and z respectively. So this will give us x plus y plus z is equal to pi. Shifting z on the right hand side, we will have x plus y is equal to pi minus z. Applying tan on both sides, we will have tan x plus y is equal to tan pi minus z. Why we are applying tan here? Because everything is in terms of tan. Using the formula tan x plus y is equal to tan x plus tan y upon 1 minus tan x tan y, and tan pi minus theta is minus tan theta, we have this expression. Substituting the value of tan x, tan y, and tan z as a, b, c respectively, we will have this expression. Cross multiplication and simplifying collecting terms, we have a plus b plus c is equal to a, b, c. Hence we are done. Coming to the next question. This is same as the previous one. So we will start with letting cos inverse x is equal to A, cos inverse y is equal to B, and cos inverse z is equal to C. Simple transformation will give you cos A is equal to x, cos B is equal to y, and cos C is equal to z. This substitution will give us A plus B plus C is equal to pi. Shifting C on another side, taking cos on both sides, applying formula of cos A plus B, cos A cos B minus sin A sin B, which is equal to minus cos C pi, because cos pi minus theta is minus cos theta. Substituting the value of cos A and cos B as x and y, and sin A and sin B, using the identity, you will have square root of 1 minus x square and square root of 1 minus y square, which is equal to minus z. Shifting z on the left hand side and the square root term on the right hand side, square both sides, we will have this expression. You will simplify and then we have the given expression. I hope it is clear to you. Then coming to the next question. Here we have to solve this equation for x. The question is tan inverse x whole square plus cot inverse x whole square is equal to 5 pi square upon 8. So let's see how to prove it. So I changed cot inverse x as pi by 2 minus tan inverse x using the property of inverse trigonometric function. Cot inverse x plus tan inverse x is equal to pi by 2. Now applying the formula a minus b whole square, we will have this expression pi square by 4 minus pi tan inverse x plus tan inverse x whole square. Simplifying, you will get 2 tan inverse x whole square minus pi tan inverse x is equal to 3 pi square upon 8. So this will be a quadratic equation in terms of tan inverse x. To simplify, you can write or assume tan inverse x as y. So this equation will be 2y square minus pi y is equal to 3 pi square upon 8. Simple transformation will give you this quadratic equation. Now using quadratic formula or simple factorization method, you can find out the value of y as minus pi by 4 or 3 pi by 4. And we know that y is equal to tan inverse x. Therefore tan inverse x is equal to minus pi by 4 or 3 pi by 4. Using definition, we will have x is equal to minus tan pi by 4 or tan 3 pi by 4. Tan 3 pi by 4 can be written as so pi minus pi by 4, and tan pi minus theta is equal to minus tan pi by 4. It means this equation has single solution, x is equal to minus 1. So this is the final answer. In the next question, we have to prove this expression. So we'll start with the left hand side by letting half tan inverse a by b is equal to x. Shifting 2 and tan inverse on the right hand side, you will have tan 2x is equal to a by b. So the given expression on the left hand side will be tan pi by 4 plus x plus tan pi by 4 minus x. Using the formula of tan a plus b and tan a minus b, we have this expression tan pi by 4 plus tan x upon 1 minus tan pi by 4 tan x plus tan pi by 4 minus tan x upon 1 plus tan pi by 4 tan x. As we know, tan pi by 4 is 1, and then simplifying, taking LCM, you will have this expression 1 plus tan x whole square plus 1 minus tan x whole square upon 1 minus tan square x. Again simplifying, you will have 2 1 plus tan square x upon 1 minus tan square x. We already know that from class 11th that cos 2x is equal to 1 minus tan square x upon 1 plus tan square x. Therefore, we can write it as 2 upon cos 2x. That is equal to 2 root b square plus a square upon b. How? Because tan 2x is equal to a by b. You can find out the value of cos 2x using trigonometric identities. It will be b upon square root of b square plus a square, and substituting here you will have the result. So we are done. The next is home assignment. Here you can see 5 questions on this slide. You can pause the video and copy the question. Thank you for watching this video. If you like this video, subscribe my channel to see more videos like this. Like my videos and share with your friends. Thank you so much.